And now, please welcome your hosts, Stefano Bini and Shauna Butler.
So I just want to say, welcome to San Francisco. Welcome to DOCSF. It is so good to be live and to be alive, right?
To be alive.
To be alive. And if any of you feel like you'd like to come a little bit closer, it makes me feel like I'm not so alone. So don't hesitate to come on up just a little bit closer. So a couple things that I'm thinking about is that I am so glad that you are here because it takes a whole lot of effort to make these things happen. And for the next 2 days, I, Shauna Butler, nurse economist, health tech enthusiast and specialist, kind of a nerd, and also the host of the See You Now podcast, which is focused on health innovation, solving really challenging problems that's driven and led by nurses. And I am joined today by my fellow health tech innovation specialist, Stefano Bini.
Stefano Bini, hi, how are you? I am Stefano, I am
You can applaud,
founder and chair. Thank you. So honored to be here before you. An audience of peers and friends looking to drive adoption of digital technologies in the field of orthopedics. But a lot of the work we're going to be doing is applicable across the board, especially the specialties in surgery. I'm a professor of orthopedic surgery at UCSF, where I do hip and knee arthroplasty, primarily revisions, but I spend a great deal of time as a CTO as well, looking to drive adoption of digital health tools within the department and also the facility.
And when he's not doing surgery, he's madly working behind a computer trying to bring all of this community together. And so I just, again, want to say thank you guys for making it all the way here. So I think whenever we gather, the first thing that's really important to ask is, why are we here?
So why are we here? Technology continues to move forward, pandemics or not, and we've seen massive adoption of the new digital technology tools, in part as a result of the pandemic itself. Mm-hmm. So it's important for us to regroup, regather, evaluate the technologies and the vision around them to see where they're going to take us next.
Yeah, and things actually have changed. They've changed significantly, and we've changed significantly. The systems that we work in have changed significantly. The people and the places where we work, those have also changed, which means we need to have a program that really speaks to that. So we put a lot of thought into this program. We've developed it into a couple of different types of sections, buckets, sectors. Why don't you outline what that journey and that roadmap is?
So the journey, it's a great way to put it actually, journey and the roadmap. We had a very interesting problem we had. We had to go from virtual, we did extremely well, worldwide audience, but we noticed that we weren't getting the sort of connections we could get in person. So we said, let's go back in person. But when we go, we have to open people's eyes up to what's possible. If we start thinking about the next 5 years, each of us has a pretty good idea of what we think is going to happen. In 10 years, most of us would agree we probably don't know for sure. In 15 years, we all can agree we probably have no idea where we're going to be. Putting us into the future allows us to think without being hindered by our preconceptions. So the first thing we did is talk about the first leg of the bucket for this conference is what's the future of orthopedics going to be like in 2037, 15 years out, to break us from the known. We also know that to get there, we need to engage in something called digital transformation. A lot of systems have done this already. Healthcare is going to be the last, but we need to do it, and there's a lot to be learned. And we also know we need to know how to get there. Yeah. Then last bucket.
Well, don't save that. Just save that. Hang on just a second. I wanted to say also, when we think about these technologies, the technologies also have changed, they've advanced, and they really are redefining what we can do, where we can do it. It's going to change how we work and the realities that we live in. I want you to go into talking about science, because we've added this whole new segment on science. Science is moving. Over the last 2 years, we've learned an awful lot about the role of science and how swiftly it moves, how we need to have patience with it. We need to participate in it. We need to analyze. We need to evaluate. We need to be rigorous. We need to have integrity about it. So we've put in a section looking at the science.
Right, yeah. And also be aware of it, because what's happening in the benches of all our research labs is going to be hopefully, in our clinics in about 10 or 15 years. And so understanding what's happening at the leading edge, the bleeding edge of technology in the research labs is also a way to look into the future.
Yeah. And we've also got a really fun partnership with Startup.health, and they're going to come here. DOCSF has always been bringing the new emerging companies that are really reshaping how healthcare operates, how we get to practice. And what are we doing with Unity Stokes and some of his portfolio companies?
Right, so Startup.health has invested in over 400 companies worldwide in the last several years, actually about a decade now. Great success.
We're not bringing all 400 of them.
No, we brought the ones that are most focused on MSK, and they're going to have a nice setup where they'll interview their company and show you talk about their moonshots and the broad visions they're having for their work.
Yeah. The other thing is that we're really good. We've been given lots of praise and credit for introducing you guys to really great ideas, the thought leaders behind it, the technologies. But the one thing we always hear is, yeah, now the hard part happens, which is how do we help lead that change within our organizations? So we have you covered on that. At the end of tomorrow, we have invited IDEO. So they're a global design firm that's going to come and join us, and they're going to help us design. Can I get that slide up? IDEO is, like I said, they're a global design firm.
Yeah, they're a global design firm that basically invented the whole concept of design thinking. Mm-hmm. And we've had them every year, but this year in particular, we organized something really quite special.
Right. So, like I said, the question that we always get is like, how do I talk to my leaders? How do I talk to the decision makers? How do I talk to the people who own the budgets, who actually are going to make these things happen? So we've invited them in to come and design with us to help us think about how you actually do those things. So as you are listening over the next couple of days, what I want you to be thinking about as you go into that is who in your organization is the champion of this? Who are the rabble-rousers? What roles do you get to play in all of that? The second thing, what are the challenges that need to be solved? And what are the doors that technology is going to open for them? And then the last thing is, why does that matter? So if you've been thinking about those, that's going to do, if we can go to the next slide. These are the team from IDEO. These are exceptional designers who are going to come in and spend one-on-one time with us for a couple of hours in thinking about how we develop that script, that role play, that scenario, that template for an FAQ. All right.
No, let's just not step for a second. I have found in my work that the hardest mile isn't a mile, it's an inch. And it's the inch right in front of the CFO's office. That getting into the office, getting that moment, and you have to present a pitch. It's like a startup is presenting to a VC. You got to have a clear understanding of what is trying to get, whether you're at a big corporate trying to move forward a project. And we think that this opportunity at the end of this conference, of all this information you gathered, to sit down with a group of peers and think this through is going to be really special.
And there's something about being able to have just the right phrase at the tip of your tongue. If we can move back into the presentation, my next question for you is, by 2037? I mean, is that a prime number?
Earlier, the 15.
Yeah. But it was like 2037. Like, how did you pick that out of a hat?
So I thought 15 years was that far enough to get people out of their understanding of what they were.
All right. So in 15 years from now, well, we know that time moves so fast. It's hard to really know what's going to happen in 2 years, 15 years. I think what that will help us to do is to really suspend your imagination and to think aspirationally, to really put yourself in that place. So I want to say the other thing too is like, who is in this room and who do we have gratitude for? Because as we begin this 2-day journey, an adventure, I should say, it's more of an adventure. There's so much gratitude that we need to, first of all, say thank you to our community who care about this and have made the effort. And then also we have some really great academic partners and industry partners that you want to shout out to.
Of course. Academic partners, the Department of Orthopedic Surgery, University of California, San Francisco, is behind all of this, and we thank them for that and acknowledge them. Also, our partners, Stryker, DePuy Synthes, and Zimmer Biomet, who have backed us pretty much every year of this conference, so thank you for that. Okay, as we said earlier, we want you to suspend belief. We want you to take a moment, and in this case, we're going to say about 30 seconds to get into the thinking about what does the future look like. So in your own world, what do you think your phone's going to look like? Will you have a phone? How you interact with the hospital healthcare system? So let's drop the lights entirely.
And probably the music, a little bit more
suspense.
suspense.
And cut the music. And let's hit play.
Today is April 28th, 2037. The world is immersed in what we once called the metaverse. Today, mixed reality is nothing more than one of the many realities I move between without giving it a second thought. I play games in fantasy worlds that are as real as the virtual office where I work and see clients. My kids visit the nurse practitioner and health coach without leaving school, and all the labs and testing are done at home using sensors, digital devices, and at-home testing kits with results rapidly available and digitally shared with their health team. My home is tracking everything about me, and I mean everything, from how well I sleep to what I eat. And my personal assistant, Andrea, is making sense of all that disparate information by prompting me with encouraging guidance and nudges at opportune moments. My insurance pays for Andrea too, as it keeps me healthy, but that's just what's on the surface. Back in 2022, we were starting to see the beginnings of what was called the healthcare revolution. AI was starting to be a thing, taking care of mundane, repetitive tasks and ensuring that resources were allocated properly. We were seeing the early signs that predictive analytics might help people make better choices. We saw billions of dollars invested in healthcare startups, focusing on the patient experience. With time, empowered and educated patients drove reforms by voting with their pocketbooks. They called it the consumerization of healthcare. Access to affordable care became a priority to anyone linked to the interwebs, which are now everywhere, from rural Arkansas to downtown New York City. Do you recall the first time we saw machine learning translated into machines that could actually learn? Looking back, it was not healthcare that was changing in the early 20s. It was the world that was changing around healthcare. Healthcare simply followed along. Perhaps a bit unwillingly at first, but it evolved borrowing cutting-edge technology from industries that had already undergone their own digital transformation. We adapted VR from gaming and esports, infrastructure and payment models from banking and telecom, and customer service. Yes, can you believe it? Customer service came to healthcare from the likes of Amazon and Best Buy. Smart chatbots replaced long waits on the phone, and all our medical data started to live on the blockchain. Now I can share my lab results, clinical history, MRI images, and anything else with whomever I want, wherever I want. And we were all so worried about this idea called interoperability. So yes, indeed, welcome to 2037. It's a wonderful world that, back in 2022, was just a glimmer of possibility. It was people like you that built this world. People with passion, people with vision, people who joined the revolution and saw it coming. I'm grateful to you. This world was worth building.
So when we think about these technologies that we want to look at that are going to change and define how we work, how we live, how we practice, we wanted to start with AI. And AI is huge and vast. And everybody that we talk to, futurists, they all agree that it is already having a massive impact, and it's going to continue to have an exponentially massive impact. But it's big, so we decided we're going to start with imaging.
Yes, imaging and computer vision. Those are two areas that we feel are going to impact musculoskeletal care the most within the world of AI, at least for the purpose of this conference. It's AI at the DOCSF venture, which we presented at JP Morgan this year, we looked at all the investments that are happening in this space, and 54% of the investments are involved in AI. So we couldn't cover the whole space.
No, we can't. But what we thought would be a good place to start is in radiology, okay? What's really interesting about radiology at this moment in time, billions of images are performed every day around the globe. The volume of storage that that's requiring, and interestingly enough, despite there being the ubiquity and the growth of the technology, according to the World Health Organization, close to 2/3 of the world actually doesn't have access to digital or to any type of imaging. The other part that's really interesting about this is how many, the size of this category in the billions of dollars just in US markets. So when we think about the role of diagnostic imaging and how it's so fundamental to our care systems, we thought it'd be really good to start with somebody who has spent their life at the very early stages thinking about how can I improve the lives of others? And he started out as a radiology technician. And there's very few parts of the radiology experience from the provider side all the way to on the patient side, every single step of the way, to the point where now he is the global strategic clinical leader and chief medical officer at Philips, and thinking very deeply about the future of medical imaging. So please welcome to the stage, Nico Stefani.
Ciao, Nico.
Okay, hopefully you can hear me. I'm always scared about this clicker all the time. That's the thing that scares me the most. So again, so thank you again for inviting me here. It's a pleasure, and hopefully I can bring a little bit of background on how AI is moving in the imaging, but also how actually as a company we are expanding outside just imaging as well. So I want to start with a little bit of background and why we need to transform healthcare. So what we see now started even before the pandemic. There are 4 fundamental trends and insights that are transforming the health in technology. And so the first one is the global constraint of resources. So again, we know now after the pandemic, components are missing, is hard to deliver on devices. But what is more important is that there is a lot of lack in finding the right labor. So when you look at radiologists, technologists, physicians, they're always less and less, and we need to do more. So the concept of value-based care and how we focus on patient outcome at a lower cost is really, at least for us, one of the key points. The second one that I'm sure you are really familiar is that the aging of the population and the chronic diseases. So how do we bring the hospital at home? How do we make sure that we are proactive and that we monitor the patient? So starting really from early detection, but also post-treatment. And tied to this is the increasing on the consumer and patient engagement. So our patient, they want to be involved. They want to be part of the decision. They want to own their own data. And again, how we can help this conversation, how we can help orchestrating their journey. And
I'm Gary Brodsky. I'm doing this by video because I tested positive for
so again, and the fourth is digitalization and AI. And I hope that when actually I finish today, you're gonna think also at Philips as something that is outside of devices, outside of the core business of making machine, because that's what we started to do, a couple of years ago, and that's where we want to play, in the next years as well. So again, some challenges that we see with our customer, mostly, 3 buckets of challenges. The first one is, as we said, we need to do more with less. Actually, after the pandemic, we see a surge of diagnostic imaging requests. So how we enlarge patient access, but on the other hand, how we make sure that our staff is comfortable. Because again, I think, when we look back in radiology, 10 years ago, there was a focus on the patient and a little bit less on the staff. But now the staff is becoming a problem. Maybe we didn't dedicate the right time to make sure that they are comfortable, that they can perform their task, and that they love what they do. And the third one that for me is the most important is that we did work for many, many years in implementing these old vendors and also institution, different IT, tooling and storage and software and packs. And I think when we did that, no one was thinking at how we are going to handle the interoperability. And in my opinion, if we don't fix and break this silo, AI is never going to work. Okay, because AI need data, need the data exchange, need data viability. So no matter if you're talking oncology, cardiology, orthopedics, or neurology, you need this flow of data. You need that also us as industry and vendors, we help you do that. So we need to work together towards this goal. If not, I don't think we can have the leverage the great power of AI. So I want to put some numbers. So again, we measure the problem, and again, at least from what we see, we have we need to engage more with the patient. We have a lot of problem. A lot of institutions that have problem with patient not be compliant with the follow-up as well. Like no-show, at least in US, is a big problem. No, so and when you have a no-show, that means that you miss a spot for a patient that actually need to be there. And other things that I want to show that, again, as I said, focus on the staff. There is really, really a shortage of radiologists and technologists at the moment. So that impact the complexity of the exam that you can perform and include variability. So, you know, how AI could help on that. And the last one is there was an increase in the last 30 years, like a temporary increase on the fold that have been used for decision making. And this is not going to get better, at least for what we think. So if you think again, 20, 30 years ago, we look at images, you look at images, now there is much more than that. Now we have images, we have, you know, we can do evaluation on quantification. In MR, you do quantification of, for example, signals, you do spectroscopy, but also we are adding different elements like pathology, genomics. So the data, they're not gonna get less. The data are gonna get bigger and bigger. So how we can handle that, how you can handle that. So as Philips, we believe in any case that AI need to be combined with a strong clinical expertise. Again, I was with one of my you know, colleagues, and again, a lot of friends in the field, and we always make a joke, no, that how helpful is a resident for you, no? So you do a lot of tasks, it can help you. So what if you have a virtual resident? What if you have a virtual assistant? So we see AI has a support, but then need a strong clinical drive, a strong clinical operation drive that support the use of it. So also, as you see, there is like an explosion of AI. You know, Stefano was at Vive, again in Miami, where I live. And I think you can see there is like so many company from startup, also company like us, is becoming confusing, no? Yeah, and so what I like to do, at least, and what is helping us as a company too, is that can we try to create some segment? Because also look at this as a progression, okay? So we start from augment the expertise, and that's the most easy. So I'm gonna show you some example of what I mean with that, but usually that's the AI that is attached to a device, okay? So pretty easy, straightforward, and again, like also from a model standpoint, is easy to be acquired. The second one is improve operation. So we said how is important to really make sure that now we reduce cost and of course we improve the outcome of the patient. And operational is key here. So how AI can drive that, and starting really from following the patient journey, from engagement, early diagnostic to really follow up. And the third one is what we are working on. It's kind of like our 2025 vision, is that can after that start to orchestrate? Can we start to be predictive? Can we use AI to orchestrate a care pathway? So let's go to some example. So when we talk about augment the expertise, we talk about assistant, okay? So as I said, there is lack of technologies. So some solution tied to devices, how can they help them do a better job? Or actually, if you have tech in training, how can actually a junior tech start to work in autonomy earlier, no? So that actually you can have more labor, more force. This is an example in X-ray, okay? So this is an application that we have that basically analyze is the right collimation, is the right positioning, is the image is good enough, you know, so that we can avoid recall and also make the tech really, like if you're having an assistant with him to support him, is their quality check. So also, you kind of like shy away to think of, okay, this is a threat to my job. No, it's a support. Same things when you start to look at CT. So what actually, instead of just having a person to position the patient, you have a camera, a AI-based camera post-processing that allowed for the perfect patient positioning so that you don't make mistake, okay? So, and you go faster. And what is more complex than ultrasound? So ultrasound, again, you need to identify the images, you need to identify the angle, you need to capture the images, and you need most of the time to do measurement, no matter if it's cardiology, orthopedics, or others. So what actually, if we AI, we can do most of these tasks in automation, okay? What actually, if we can really reduce variability, and it was during COVID, at least we saw that there was a lot of lack of expertise, for example, to perform lung ultrasound. And this kind of application have helped actually to increase patient access, for example, when you triage a patient that come in an emergency department for COVID. So there was actually not a lot of radiologists that were used to do lung ultrasound. So AI in that case has helped to enlarge the patient access and to actually have them, have them a better triage. So we have many, many things. As I said before, you can go from really like to orthopedics, to lung, to cardiac, to neuro. So probably this is the field where you have most, the support of the insight around advanced reconstruction. And it's the easy part because usually you get as part of your system. Even if for us as a company, I mean, it could be a big effort, but we really perceive that without this, again, the device, they're not going to be smart enough to be used. But let's think about a little bit the patient journey, because I think that's where everything can resonate. So we talk about patient engagement. So the patient engagement starts really from the first exam. And we have, some solution that has many of you probably saw. They engage with the patient, they send text, they give reminders. So, all good things to keep the patient engaged. But what if you can use all these data, okay, to start to create patient profiling? Okay, so what is actually all this data that is not like statistic, is not research studies, your data, and you use an algorithm that is start to maybe identify the patient that maybe they're not gonna come back for their follow-up, or the patient that, usually they arrive late. And tied to that, what is gonna happen, the system automatically is gonna send more reminder. It's gonna treat the patient a little bit in a diverse way. So when you start to really have a personalized engagement with them. And after the patient, they need to arrive. So we follow the flow. They need to arrive to the hospital or to the imaging center. And, we have a problem because the patient could be late, or a system, it could be down for a couple of hours. So what if in real time, okay, AI can suggest and can modify the schedule and tell you, in this moment, this is the best CT scanner, this is the best MR scanner based on the configuration and the clinical ask to perform this patient that maybe is arriving late. So real-time schedule recommendation. Okay, that's what kind of like AI can do. So now we are optimizing the preparation of the patient is showing up, and now we have the perfect system to perform the patient. And we go to the image quality. I think everyone is really interested in that. But what we can do there? Of course, we can improve the image quality. But for CT, as example, we can have the same image quality, maybe better, but we can have a reduction in the dose for the patient. Okay, so more consistency and a reduction in patient dose. And what about MR? That I think everyone is really familiar. We can use AI to speed up the exam or to make the exam with high resolution, or we can have a compromise. So we all know how actually it's difficult to have a patient standing still in MR. So if I can, in this case, with AI application, to have a reduction in time, of 8 per, that means that a sequence that was before 8 minutes go to 1, or a sequence that was 8 minutes go to 4, but you have double of high resolution. So it's really helping us, again, keep the patient flow fast. And after we need to read, and also you, for example, you need to get the report. So what if the work list now is powered by AI? And what I mean with that is that we have AI that analyze the critical finding on the images, they flag them, and based on the critical finding, create a prioritization in the work list so that the radiologists, they need to get to that patient in a certain time that we define. So imagine there is a patient coming for a stroke, the system identify the images and prioritize the patient for the stroke to be read in the turnaround time that is defined by the department. So in this case, we're gonna enable the radiologist to focus what has priority, or a pool of radiologists to do that. So you see, we are really trying now as a company, but in general, the vision, we're not only doing imaging, no, we're trying to kind of like facilitate the patient experience, the staff experience, and make much more efficient and lower the cost. So now we get to the last, the most visionary, the most interesting, talking about care pathway. And again, here you see some reference to oncology. That's where we start. But again, this is again why I'm here, because after I would like to hear your suggestions. So please stop me when you are around if you have some thought about it. But when we talk about care pathway, it could be everything. No, it could be really any application in the field. And our desire is that to try to create, and we started with oncology and cardiology platform that are aggregating all the data. So when you talk about, when you see about this graph, you talk about early detection. And when you have an early detection, you have a software as example that automatically could schedule a follow-up exam or schedule like a visit with a specialist. So you don't need to do it. Just like based on the report structure, you can use natural languages recognition, and your patient, he gets served, and he know what is his step pretty fast. And after, you integrate everything in one platform. So imagine if this patient has a history, if you have, again, imaging, if you have genomics, you have pathology, you have all at glance in one screen. I'll show you later how it looks like. And based on this, you can start to create a treatment that is based on evidence. So this is not about, of course, only the personal expertise, but you could have database. You could have actually a sharing experience that can suggest a treatment course for a special patient. So when I talk about precision medicine, it's kind of really like all this data aggregation and AI could help us doing that. And the care team can collaborate around that suggestion and can actually decide what is the course of the patient. And after that, everything that is happening after that, monitoring and all the data that we could actually acquire with devices at home, that can get still back to that platform so that we can proactively engage with the patient if something happens and make sure that actually they are compliant with their follow-up. So if you look at this is, again, an example in oncology. What if you have access to something like this, where really like you have, again, we're usually to look at the patient history, but what if this data, they become actionable? Because as soon as you put all this data together, that way you can really unleash the power of AI, because at this point you can really like use all of this to define and to start to be predictive and see how the patient journey can be really orchestrated from one place. So I think I want to close with this slide where I say that we start with a problem, okay? Here you see some evolution. Again, we started this three years ago. Here you see some evolution that we are making that kind of like problem a little bit less. So we are still far away to fix the problem. But the message for me here is that AI is cool. And again, as you see, he's helping to really like improve all these, let's say, single application and phase of the patient journey. But if we don't put everything together, so if we don't work together between institution and industry to put all the data together, we will never be able to influence like the overall care pathway. So that's really like what is always a prayer, to our customer to help us, make this step in digital transformation so that we can really do much more with AI than we do right now. Thank you.
So you can just stay up here with me because I got a couple questions for you, if I can get this off. So first of all, this is a really special place in my heart because the technology bug bit me. I was part of the team that got to put in the very first digital radiology solution.
Perfect.
And at the point in time when we did it, and this is, I don't even want to date myself, but it was a while ago, and it was in another country. It was New Zealand. They were the very first ones to do this. There was the business case, like the efficiency. But what we found is that it dramatically changed how we practiced. I mean, we were thinking remote collaboration, but it wasn't until we actually had these on these screens with people on these different islands and very remote places that we saw the ability to zoom in, to change out. So it had these unintended or unexpected benefits. So one of the things that they were working with, and a lot of people, and you mentioned this, as everybody knows, we have a major healthcare workforce crisis. And in the last couple of years, the attitude has been, this is going to take away my job. And I have a feeling that that's what you're getting. Now the tune is, how can you get this faster into my practice because we don't have enough people? So can you say more about what you're seeing as far as a response that's changed where people are really anxious to have, eager to have it in, not anxious. Well, they probably are anxious.
No, I think that's hopefully you can hear me.
Yeah.
That's a great point. And I think, yes, we start to speak about AI, 20 years ago, 15 years ago. And again, especially on the radiology side, there was like, okay, what does this mean for me? Actually, the technologies at that time was not in the picture, to be honest.
No, it wasn't.
It was like, reading. Mm-hmm. Now everyone needs it. So everyone, as I said, when I make the example of the virtual resident and this kind of example is coming, is because they now start to see for this kind of task I need it. It is not going to impact my professional, so they need that. What is the roadblock, as I said before, that we start to see right now, how you implement it. Yeah. So different.
Okay, so I have been to the Philips grand headquarters. I lived in the Netherlands for quite some time. And one of the things, Dutch is a really hard language, as is Chinese, Japanese, all these others. With the use of AI, what can we see as far as changing accessibility from a language perspective? What are some of those things that we haven't been able to do without AI and massive amounts of data that maybe we can have better radiology services in a lot of languages?
I think, again, far away from that, but again, I think there is a lot of work in interoperability. There are still just for also privacy and different rules into the country. So, for example, when you start to show or medical records or other stuff, email report that go from US to Europe, is a completely different way, handling, and also the GDPR and everything. So that's still a little bit like stopping us to do that. What I can say is that when we talk about follow-up and natural language recognition, that's instead is going really well. So, for example, everything we are thinking is multi-language. So when you need to have a natural language recognition on a report, it's going to work on English, but it's going to work in Chinese. That is more difficult. But again, we are looking to make, of course, like this kind of AI reachable to everyone.
Okay, so then my other question, final question for you. When you're talking about patient and data, and we are asking people to trust us with more and more data, headline, 1 billion medical images are exposed online as these images are rapidly becoming available and being shared, and we're using some older, the DICOM technology, some of those things, but it's a lot.
Yeah.
So how, if we really want people to trust us and to be fully on board, your health systems are feeling a sense of risk because there's a liability there. There's a potential of being, I guess the data's, exposed, but also hijacked. Yeah. And then just losing trust with the system. A lot of patient data gets exposed.
I think this is a good question because, again, some years ago we started to talk about clouds. Everyone is, I want the cloud, I want the cloud. But after, when actually we go to customer and we say, we have this software, you can choose on-premise, on clouds. Everyone say, I want on-premise. So, and now it's changing, but the reason exactly for that. So as Philips, but in general, of course, we work a lot on, cybersecurity is our top kind of like priority when we do this solution. We work with, again, we are partnered with Amazon. So we work with the, partner that they know what they do. We don't build the Philips cloud, and so that's kind of like giving us, of course, a lot of reputation in that. And a lot of customers, they're starting to have, what we're trying to basically enable is to be compatible with them so they can have their own clouds, their own storage. So our really motto is you own your data. We help you inside your network, inside your firewall, inside your way of working. We help you put the right system in place. But we don't handle, we don't share, we don't really even get your data. We work inside your department. So that's really the 3 point that we try to make.
So everybody here is going to get objections when they come and bring back in. What's the common objection, the most common, and what are you doing to it's not so much overcome it, but how do we get people on board to get more confident and eager to embrace everything that this has to offer?
For AI in general?
Well,
Or for the
we'll just do imaging for us.
Okay, for imaging. No, I think for us is that we need to start to get together and again put together the imaging department, the CIO of the words, the CEO. So these people need to get together. So because each person has his own goal, and sometimes the goal, again, I don't tell anything new, sometimes they could be a little bit conflicting. No, so I want the best imaging, but I want the best performance, and everyone care about his own thing. So I think we just need to look at much higher level, and imaging is just a tool to enable a better care. So it should be usable for all the one that need it. And so when we use for oncology or cardiology or orthopedics, we need to have the same access, the same possibility for everyone, and we need to break a little bit this silo that, again, imaging is its own bubble. So that's really what we're trying to do. So that's why we're trying to bring these people together and change the audience. That is not only the radiologist, but it start to be, the C-level, the administration level, and the whole care team. And we listen to the orthopedics as well, and we listen to the radiologists.
And to the nurses,
so
right?
The nurses, everyone that, of course, they matter a lot. So that's good.
Well, thank you so much for bringing the light into a very dark space.
Thank you so much. Thank you.
I want this. So when we think about the other segment of AI and imaging, computer vision is everywhere. When you think about our security systems, manufacturing inspection system, autonomous unmanned vehicles, computer vision is essential. And of course, it is in all of our digital imaging. What happens with computer vision? We've got somebody who's expert who's going to help us understand this. But part of what's happening is that there are data and images that get stitched together to help us see things, and oftentimes to see things that we don't actually see, that we're not trained for. Our guest, unfortunately, tested positive for COVID, and so he's sent over a video for us to be able to share. But Gary Brodsky is the founder of Opencv.ai. It is the world's largest library. It's been around for about 20 years. It has over 1 million lines of code. It's free and available for research and commercial. And there's probably nobody better to help us understand this computer vision than Gary.
Hello, I'm Gary Brodsky. I'm doing this by video because I tested positive for COVID. I'm okay so far. So I'll be discussing Opencv in the future of computer vision. So a little intro to Opencv. It's both a computer vision library and a nonprofit foundation, as we state here. It's the world's most popular library. It gets about 200,000 downloads a day, mostly through Python. It's mature. It started 20 years ago, mostly in C++, but has interfaces in Python, Java, JavaScript. It's large and comprehensive. It's widespread, has a large active community, and it tends to be decently efficient. So the areas that the library covers are, as you can see, image processing, geometric transforms, image fitting, optical flow, segmentation. On the bottom, calibration and geometry, SLAM, depth, deep learning. It does inference very efficiently, especially on edge architecture and computational photography, and includes the supporting data structure and other interfaces to that. So this is just a look at our sponsors. We have a lot of large and smaller corporations that we work with. So Opencv has a commercial side separate that does contracting. So here you can see some of the things that we've done, a lot of medical work, sports work, AR, VR, and a number of things like shopping and grocery checkout shopping and other things. We also partner with hardware. So this is a smart camera, the Opencv AI Toolkit. It's a depth camera that's smart. It has 4 teraflops of processing on it, so it does stereo and deep nets on it, and this is used quite extensively. We also offer this marketplace of models, many of which work on the Oak, and they tend to be optimized and highly functional. So there's a little video showing what some of the things that are being offered, and there's a little representation of some of the things on the left. Okay, Opencv is used all over the place, as I said. It's got many millions of downloads, 200,000 downloads a day, at least for Python and BuildBots. And so we'll cover some of the uses, just a few, in video and broadcast first. So on the left, you can see image stabilization. On the right, very robust trackers that we have. So tracking objects and tracking for stabilization here. And I'll just let this go a bit to watch. Anyhow, moving on. We also do things like colorization, as you see the original video on the left and the colorized version on the right that's being done in real time. Here's segmentation. Above is someone in their living room, and then they're cut out and put in a scene. Below is driving and through streets, so for automotive. Some other things we did in broadcast. Here's stable tracking on the left, that from a drone, and on the right was some movie work. You can see, you can overlay very stably a fictitious car, so that car isn't there. It's just a dune buggy, and this was done on stage in the movie form. And Super Bowl stadium footage is on left, so very stable tracking that we're able to do things with. So here's some pictorial tools that are useful. There's a lot of stuff: factorizing, lighting from surface. Below that is color calibration, Macbeth charts, and high dynamic range. Other things are, as we've seen, colorization or color transfer. That right, color constancies, so trying to keep a constant color in a scene. And then some fun stuff like tilt shift photography to make things look like a toy model. Here's cartoonization, super resolution. As a small resolution image is blown up, you can see the blur, but it's restored on the right, and this can be done in medical imagery as well.
Opencv is used extensively in robotics. So here's some of the list. It's used in industrial pick and place, it's used in logistics, it's used in eyelash placing, it kicked off autonomous driving, it's used in factories, on to home vacuum cleaners. So this is a use we did, Industrial Perception. It's a company that sold to Google, and here, just for fun, we actually did this for Larry Page's birthday party, where we were handing out party favors using this. Opencv was instrumental in autonomous driving, and this is a DARPA Grand Challenge where Stanley, our team, won the $2 million prize and really kicked off autonomous driving. So here you see BOSS, the CMU, is starting off, and that's followed by Stanley. Just skipping ahead, there's the race as it went. This is when we were passing BOSS. You can see the 3D LiDAR scan, and then going down the mountain pass and on to the finish line as you see it coming. So here's some more modern uses in autonomous driving. So lane detection, car detection, sign detection, pedestrian detection, stoplights. And recently we've been using this in agriculture. So on the left is road detection and path planning, the path to follow, people detection. And on the right you see a robot that's following a person for, say, harvesting. They can carry things on it, and then the person can walk down the row And we'll just show a little bit of this as we speed it up. So it follows him wherever he goes and stops when he stops. Okay, Opencv's use in, or Vision's use in medical. So some of the things that have been done are skin detection for treatment and conditions. This is a summary of a lot of things that have been done in vital sign detection by a regular camera, blood flow, again by a regular color camera, and we got first place in a 3D tomography segmentation in 2020 contest. So other things that can be used, this is body tracking. This is also used for sports, but any motion and identifying body parts. So it's pretty robust. This is a robotics application in Eyelash Extension. So this is someone's eyelash, and it's epoxying new eyelashes onto it. That's by Loom. So here's a Odena is doing using Opencv for pathology detection, as you can see. So moving on to new areas. So here's a list of emerging areas. So self-supervised learning, use in driving, understanding, autonomous driving. Deep vision on edge devices, so we saw the OAK-D camera already. Predictive 3D solutions to protein folding, that's AlphaFold, upper right. Growing use in agriculture, I already showed that. This is FarmNG, the tractor, for example. Use in medicine, below center is Gauss surgical blood loss tracking. And generative models for art and description, that's bottom. And also for understanding causality, which I'll talk more about. So first, self-supervised learning. Here's two examples of what is done. On top right, we mask out a lot of the image and ask the network to predict the rest and iterate on that at different images. So it learns to the structure of images. In the bottom, we see we get a bunch of images and do transforms of them, but in the middle of that network, it's focused on learning the same representation for this object. In this case, it's a dog, and then you'd feed other objects in. And so it learns this representation to be the same for each object that it happens to pass. Here's an example of deep generative models. So, for example, upper left, it's asked to draw the same cat in a drawing manner, and the network generates that. Bottom is a chair in the shape of an avocado, and that's generated by the network, and so on. This is a neural radiance field, so it learns a generative compact model of an object, and this is using the OAK-D camera. This was for a contest we ran, and this is it. It's just a Lego set, spinning object. It's learning a few views, and then it learns to generate this object from any view. So almost none of these views have been seen before, and it's just generating because it has learned a full representation. The network itself represents this object. And you could see possible uses with speeding up MRIs by being able to capture basically the whole thing in much fewer views. So lately, and to me most exciting, is the learning causal models. Those are descriptive, what happened, explanatory, why did it happen, predictive, what will happen next, and counterfactual, what would happen if. And so there's a lot of work going into this. To me, this is getting closer to real AI, and so you can see a causal model on the right that's learning these things about this physics scene. And the results, as you can see in yellow, are much better. Descriptive has already been done pretty well, but explanatory, predictive, and counterfactual are much less progress, but this model's done substantially better. So this kind of thing is starting. So I'm going to end this talk with talking about causal simulation as it pertains to general AI through vision models. Okay, so we ourselves have a causal model of the world. We don't perceive the world. The analogy is, say, on your computer user interface. For example, there's a trash can there, but I'll tell you, there's no real trash can inside your computer. And physicists will say, you're right, the trash can is made up of quanta, pixels. But that's wrong. The real reality is this strange von Neumann architecture beneath it all. What's true is we have a causal model, so if you move things into that trash can, they'll be deleted. This is an analogy for our own perception and any perception. So here's an example. It's a famous Conixa triangle. So you have illusory completion of the boundaries if you're looking at this from the right distance. And the brain is imputing this causal model that it's actually in 3D and the triangle is floating above these complete circles. And that's how this illusory contour is inferred from vision. So we're not seeing the world, we're seeing a model of the world. It's a causal model. And again, this is simple when you think left about just points of view of two objects in 3D. You can see it, the pictures below show you get a completely different percept, yet we perceive it the same. And so on right, there's a famous, this is in Stanford's Hall, a famous illusion. So you can see when something is seen in 3D versus the actuality, the scene looks normal to our view, but when you move the guy in back forward, it looks very strange. So the outer world is actually a causally simulated inner world. The outer world exists, whatever it is. We create a causal model of it that's much more sparse. And so, you know, here's some drawings by my friend of this. So the simulation is causally sufficient, but it's not true. It doesn't contain the whole world like any model. And so I like to say, what is beyond the sky, right? Above you, what's beyond the roof? Well, it's the inside of your skull, and this is pretty obvious on reflection. So we live in our own simulation bubbles. I like to say, when you wake up, the dreams don't end. They just connect to a data source. And so we're simulating the world kind of like we live in our own matrix, if you saw the movie. But it's not a machine, it's our own perceptual apparatus. So we simulate also our social selves and the social dynamics. You'll see this in the dream when you meet people, and often there's things you're discussing, and in fact, you simulate yourself also. So when we apply a social simulation of others to our model of ourself, then I'm suggesting that that's kind of the pathway to self-awareness or consciousness. And that's where I end this talk. Hopefully I'll be around for questions.
Your key insight that when you heard him first talk about this, you emailed me right away and said, oh, this whole thing about seeing things.
Yeah, so had the opportunity to speak to most of our speakers ahead of the situation, so I can understand where they're coming from, the point of view is. And I've had always insights, but that last piece to me was just one of those moments where you stop and realize that you just learned something that changes the way I think. If we started discussing computer vision, and the computer can't see things it's not programmed to see. So what we saw for the last 20 minutes is how they program computers to see things and how good they're getting at them. Not just first at defining things, but then inferring things and now creating within what they see causal relations that actually create a series of things that happen that actually meet physical standards, like physics. There's little balls that are hitting each other. Now, he then switched to say, well, he kind of offhandedly said, well, of course, that's how we see the world as well. I'm like, well, no, that's not how we see the world. I see the world. I see everything. My perception is that I see it. And he's like, well, no, you see a very small part of it, and then you interpret it your own way, and therefore you really don't see anything. And I was like, okay, let's go over this again.
Yeah.
What? So it reminded me.
You see what you want to see.
You see what you're programmed to see. It's not what you want to see, it's what you're programmed to see. You can program yourself to see things. But the thought I had at the moment, I'll share it with you, and then we'll get back to this, is this idea that my wife and I went on a safari when we got married. And I would get out of the Jeep, and the guys would say, hey, see that leopard up there or whatever, that lion? I'm like, no, I don't see any lion. It's like, no, it's right there. It's like, I don't see it. They give me that goggles, and I still don't see it, where it's on the third branch. I'm like, third branch, if I see it, and they can see it from a mile away. They've been trained to see it. I can look at an X-ray very quickly, and I can see a fracture. Other people who aren't trained in it can't. It was just an interesting mind shift that we actually perceive only that which we're trained to see. And if you start applying that to everything, from politics to medicine to everything, you have a bit of a shift in the way you think about perception.
And this year at South by Southwest, Amy Webb, who's a futurist, she gives the Tech Trends talk every single year with the Tech Trend report that they bring out. And the theme that she has this year is reperception, just because of AI. I mean, that's the big piece. And she opened up the conference with this screen up there that looked like it could have been some type of an X-ray film. Bunch of pieces missing out. She said, what is this? And people are looking at it, and they can't see it. And she said, and I'm going to rewire your brain, because I'm going to outline it and I'm going to show it to you, and then you're going to be able to not see it. So, people are staring at this. And I actually thought it was like a skull with a dental X-ray on the side view. When she started outlining it, it was a front-on of a cow. And so when she outlines the ears and the eyes, I'm like, oh my gosh, it's right there. And she said, that's the thing about the future, is that it's right there. The data doesn't change, but our ability to perceive it and our ability to have the vision around it. So taking that in mind, she said, when you look at all of these new technologies and these things are presented to you, just know that a lot of this is we have to have reperception. A lot of the, that's what computer vision is doing on the technology level. But I think as humans, we have to be open to that reperception.
And in many ways, that's why we're here this week.
Yeah.
To rewire you to think about technology differently and how it can help you in whatever aspect of digital health and technology you're going. By seeing what's possible, possibly will trigger an idea what's feasible, but also realize that if you judge the future with the lens of the past,
you're going to miss it.
You're going to miss it.
You're going to miss it.